Good evening, students. As the Telangana State Board announces the IPE examination on the October 25th onwards, already date is announced. You are very well known about the date, and our Roots Academy announces the free online YouTube classes for your revision of the IPE classes. So please utilize these classes to motivate yourself. So it is the public live, Nana. So this is the public live. Please utilize this public live. So for the free YouTube classes, because to motivate yourself, we explain the very important questions as per the day-wise schedule. 8 marks questions, 4 marks questions, and 2 marks questions. Long answers, short answers, and very short answers. Yes. Please utilize this opportunity and to enhance yourself and to get out of full marks in chemistry 60 out of 60, physics 60 out of 60, and mathematics 150 out of 150. Okay, so please utilize this opportunity. So this is only possible at our Institute of Roots Academy. So our Ramadhan sir is the very kindly hearted person. So he gives this kind of this announcement to make the utilization of the students. Right, Nana? Yes, please utilize this opportunity. As now I discuss the questions one by one. Yes, Nana, yes. What I am saying for the examination, Radha, what I am saying for the examination maximum, that is enough. Because the papers are not, difficulty papers are not given for IPE. Okay, so this is a kind of the examination. That's why very easy papers are given. Difficulty kind of the questions, difficulty models of the IPE questions are not given. Please believe the faculties. Okay, maximum what the questions were explained, that is enough, Nana. Understood? Yes. Now go to the questions explanation one by one. Yes. See what is the first question. So this is the one of the important 8 marks question. Now see, what are the postulates of Bohr's atomic model? What are the postulates of the Bohr's model of the hydrogen atom? Discuss the importance of this model to explain various series of the line spectra in hydrogen atom. That is the question. Right. So how you attempt the 4 marks question? For 4 marks question, how you attempt the questions? 4 marks and 8 marks. So you write the answer in the point wise manner. You get the good marks, you write the answers in the points wise, right? See the postulates of Bohr's atomic model. S. And see the first point, this is the nucleus. Now around the nucleus, what happens according to the Bohr's model? Electrons are revolving. Yes or no? Electrons are revolving in the circular orbits around the nucleus. Electrons are revolving in what? Electrons are revolving in the circular orbit, either in the clockwise direction or in the anti-clockwise direction. Yes or no? Now, as per the Bohr, the circular orbits was announced by the principal quantum number. So, for the circular parts, Niels Bohr give the principal quantum number. Now, for example, say, what is the meaning of stationary orbits? You write as a points wise like this. So, what is the meaning of the stationary orbits? Stationary orbits are also called what? Stationary shells. That means, see, as long as electrons revolving, what I am saying, as long as electron revolving in the circular orbit, neither no lose of energy, neither gain of energy, neither energy loses nor energy gains. What I am saying, Nana, as long as electron revolving in the stationary orbits or shells, so energy neither loses energy nor gains. That's why they are called what? Stationary orbits. Now to these stationary orbits, according to the scientist Niels Bohr, he announces the principal quantum number. Announces what? Principal quantum number. The symbol of the principal quantum number is what? Small n. Now see the next point. To that principal quantum number, say, if n is equal to 1, that is called k orbit. If n is equal to 2, that is called L orbit. If n is equal to 3, that is called what? M orbit. If n is equal to 4, that is called n orbit as given by Niels Bohr. Now see, so this is the nucleus, around nucleus. This is the n is equal to 1, that is called k orbit. Now n is equal to 2, that is called what? L orbit. Now n is equal to 3, that is called m orbit. Now n is equal to 4, that is called what? N orbit is given like this. Now, what is the next point he announces? According to the scientist Niels Bohr, as principal quantum number increases, tell me what I am saying. As principal quantum number increases, see the energy of the orbit. As principal quantum number increases, energy of the orbit increases, size of the orbit. Simple points. Have no confusion on it. So getting of the IPE marks 60 out of 16 chemistry very easy. Okay, simple logics. As principal quantum number increases, energy of the orbit increases, size of the orbit also increases, and the radius of orbit also increases. This is the second point. Tell me what is the first point? I said that what is the meaning of stationary orbits? As long as electrons revolving in the stationary orbits in the circular manner around a nucleus, energy neither loses nor gains. That is called stationary orbits. That is the first point. What is the second point? As principal quantum number increases, energy of the orbit increases, size of the orbit increases, and the radius of the orbit increases. Now the stationary orbit shown by the symbol small n. What is small n? Small n is nothing but principal quantum number value. What is small n? Principal quantum number value. Now small n is equal to 1, that is called k orbit. N is equal to 2, that is called L orbit. N is equal to 3, that is called M orbit. N is equal to 4, that is called N orbit, like that go on. Understand what I am saying? Yes. And see the fourth point. So the fourth point given by Niels Bohr, see, so actually around the nucleus, electron is revolving around nucleus in a what manner? In a circular manner. As electron is revolving around a nucleus, electron can show its own angular momentum. Electron show its own what? Angular momentum. Therefore, as per Niels Bohr said that angular momentum of electron. What I am saying? Angular momentum. See, angular momentum of electron. What is the meaning of angular momentum? Angular momentum of electron. MVR is equal to NH by 2 pi. MVR equal to what you write? NH by 2 pi. That means what? As long as electron revolving around nucleus in the circular orbit, angular momentum of electron is the integral multiple. Is the what? Integral multiple of h by 2 pi. Is the what? Integral multiple of what? H by 2 pi. What is the meaning of integral multiple? Integral multiple means what? N value is taken as 1, 2, 3, 4, 5, so on like that. That means what? N value is 1. That indicates what? Angular momentum of the electron in the first orbit is integral multiple of h by 2 pi. N value 2 means what? Angular momentum of electron in the second orbit, that is 2h by 2 pi. N value 3, that means angular momentum of electron revolving in a circular orbit is equal to 3h by 2 pi, like that. This is the fourth point. Understood what I am saying? Yes, this is the fourth point. And come to the fifth point. Already I said, see, actually around the nucleus, see, this is the point already I said now, around nucleus. So this is the k orbit, you are very well known, and this is the what, nana? L orbit, you are very well known, and this is what orbit, nana? M orbit, very well known. For k orbit, n value is equal to 1. For L orbit, n value is equal to 2. For M orbit, n value is equal to 3. Yes or no? And each orbit associated have its own energy. Each orbit associated have its own energy. So because each orbit is associated have its own energy, now electron transition takes place between the orbits. What I am saying, Electron transition. Electron transition takes place. Easy logic, no confusion. Electron transition takes place between the orbit. Between the orbits. What is the meaning of electron transition? Electron transition means jumping of electron. Electron transition means what? Electron transition means jumping of electron takes place between the orbits. That means, see students, what I am saying, for example, electron jumping from low energy level to high energy level. Now energy absorption happens. What I am saying, electron jumping from, what I am saying, as principal quantum number increases, energy of the orbit increases. Yes or no? Earlier I said as a third point. As principal quantum number increases, energy of orbit what happens? Increases. That's why electron jumping from low energy level to electron jumping from low energy level to higher energy level. Electron jumping from low energy level to higher energy level. Energy absorption happens. What happens, students? Energy absorption happens. So energy absorption takes place that leads to the absorption spectrum. Leads to what kind of spectrum? Which leads to the formation of absorption spectrum. Yes or no? Yes. Leads to the formation of the absorption spectrum. Understood this point? Very good. For example, electron jumping from higher energy level. So actually, in case of KLM, which is the high energy level? So M is the high energy level. If electron jumping from higher energy level to lower energy level, what I am saying? Electron jumping from higher energy level to lower energy level. Now energy emission takes place. These points are very important. Electron jumps from higher energy levels. Electron jumping from higher energy level to, it's easy points, very easy, lower energy levels. Electron jumping from higher energy level to lower energy level. Energy liberation observed, that means energy released. Now, because the release of energy takes place, which leads to formation of what? Leads to formation of emission spectrum. Leads to what? Formation of what kind of spectrum? Leads to the formation of the emission spectrum. One of the beautiful, nice point. In this way, in the given atom, emission spectrum and absorption spectrum is observed. Simple logic. How you get absorption spectrum? Electron jumping from low energy level to high energy level. Energy absorption takes place that leads to the formation of absorption spectrum. Now, the electrons present in the high energy level come to the low energy levels. So the excess energy liberated in the form of heat. That liberated heat forms the emission spectrum. So these are the important postulates of what? Bohr's atomic model. It's very easy, Nana. I said the points, revise the points once again. Is the one of the important 8 marks question. See the concept once again. So in the given atom, around the nucleus, stationary orbits are present. Now the stationary orbits are shown by the symbols of principal quantum number n, small n. N is equal to 1k, n is equal to 2, L, n is equal to 3, m, n is equal to 4, so on like that. What is the meaning of stationary orbit? As long as electron revolving in a circular orbit around a nucleus, energy neither loses energy nor absorption takes place. That is the meaning of circular stationary orbits. That point is completed. And come to the second point. The stationary orbit is shown by the symbol of the small n, n is equal to 1k, n is equal to 2, L, n is equal to 3m, like that. That is point 2. And what is point 3? You want 8 marks, out of the 8 marks for the essay question, you write as a point wise. Now the examiner is easy to impress. Okay, now, and come to the third point. Third point is what? As long as electron revolving in a stationary orbit have its own angular momentum, electron can show angular momentum property. The angular momentum of the electron equal to integral multiple of h by 2 pi. What is the meaning of integral multiple? N means what? Principal quantum number. N is equal to 1, N is equal to 2, N is equal to 3, 4, 5, 6, 7, like that. Therefore, what is the formula? Come across. MVR of electron. MVR means what? Angular momentum of electron equal to NH by 2 pi. And come to the fourth point and fifth point. And regarding those points, electrons are jumping from low energy levels to high energy levels. Energy absorption takes place that leads to formation of absorption spectrum. What is spectrum? So appearance of the lines over the background. Absorption means what? Appearance of the dark lines observed over the bright background. And what is the meaning of emission spectrum? Electrons present in the high energy levels, they fall to the what? Low energy levels. Electrons present in the high energy level fall to the low energy levels. Energy liberation happens in the form of the heat. Energy liberation happens in the form of the heat that observed as a emission spectrum. What is meaning of emission spectrum? So getting of the bright lines over the dark background. Emission of what? Bright lines over the dark background. Understood what I am saying? That's the important postulates. And see, what are the limitations of this Bohr's atomic model? The limitations are also very, very important, because when you write the merits and write the limitations, also very important. For limitations, you have the 1 or 2 marks. Out of the 8 marks, 6 marks for the postulates and go for the limitations. Now see, so what are the limitations? The limitations of the Bohr's atomic model. So what are the limitations of the Bohr's atomic model? So regarding the limitations of the Bohr's atomic model, actually what I am said, tell me what I am said. So angular momentum of the electron, MVR. MVR means what? Angular momentum of electron is equal to NH by 2 pi. Is it? But for this formula have no experimental proof. What I am saying, have no experimental proof for this formula. The experimental proof is given by the de Broglie scientist. Experimental proof is given by whom, Nana? De Broglie scientist. And the next point is what? Regarding limitations, Zeeman effect and the Stark effect is not explained. Tell me what effects are not explained? Zeeman effect and the Stark effect not explained by this Bohr's atomic model. What is Zeeman effect? What is Stark effect? When the atom is subjected to a strong magnetic field, what I am saying, when an atom, simple logic, when an atom subjected to strong magnetic field, simple point, when an atom subjected to strong magnetic field, each spectral line divided into fine lines. Each spectral line divided into fine lines. Okay, so this is what not explained by the scientist Niels Bohr. And what is Stark effect? When an atom subjected to electric field. What I am saying, when an atom is subjected to strong electric field, tell me what I am saying, students. When an atom is subjected to strong electric field, now the each spectral line is divided into what? Fine lines. That's why Zeeman effect, Stark effect, not explained by this Bohr's atomic model. So these are the important limitations. And also the quantum mechanical model of the atom. What I am saying, the quantum mechanical model of an atom not explained by scientist Niels Bohr. So these are the limitations. What is the meaning of quantum mechanical model? Quantum mechanical model means wave nature of electron was not explained. What is quantum mechanical model? Quantum mechanical model means dual nature of the particles, because the electrons, protons, neutrons, atoms, molecules are microscopic. For microscopic particles, dual nature is there. The dual nature of the atom not explained. Quantum mechanical model of atom is not explained by scientist Niels Bohr. These are the important limitations of what? Bohr's atomic model and see. So what is the next very important point? Now, so these are important limitations that is completed. Next, so what is the point given? Actually, up to here is 8 marks. This is also one of the important questions. Two questions combined are given. Discuss the importance of this model to explain the various series of the line spectra in hydrogen atom. Now I discuss about line spectra of the hydrogen atom. How explain the line series of hydrogen atom? Simple logic explain. So you take one discharge tube. Now the discharge tube is filled with what? The discharge tube is filled with the H2 gas. Tell me, the discharge tube is filled with what gas? H2 gas. Now, for the discharge tube, one outlet is there. So this is the outlet of the discharge tube, right? Now, by sending up the high voltage, nearly the high voltage of 10,000 volts, nearly what I am saying, high voltage of the 10,000 volts. This is what? So, anode plate connect to the positive pole of the battery, cathode plate connect to the negative pole of the battery. Now, by supplying of the 10,000 volts of energy, 10,000 volts of the power supply at very low pressure of H2 gas, low pressure of 0.01 mm of pressure. Now, by sending out the high voltage H2 gas inside discharge tube, H2 gas is breakdown. H2 gas, what happens? Because of the high voltage, H2 gas break down into H atoms. What you got? H atoms. Now these H atoms are bombarding. What I am saying, students? H atom bombarding with each other. When H atoms are bombarding each other, because of this bombardment, what is the meaning of bombarding? Because of this bombardment, what happens? So the energy liberated. Because of these collisions, what happens? So the energy liberated in the form of blue color of light. Energy liberated in the form of what color? Excellent point, Nana. It's not there in the books, but nice point. Energy liberated in the form of blue color of light. Now, this blue color of the light, so the energy liberated in the form of what? Blue color of light. Now, the blue color of light is passing through a prism. The blue color of light is passing through what? The blue color of light is passing through prism. Now you can observe different kinds of the spectral lines, different kinds of emission of line spectrum. Different kinds of emission of spectral lines are observed. Different kinds of emission of spectral lines are observed. This is the explanation. Repeat the explanation once again. Simple logic, no confusion. So H2 gas taking discharge tube, connect to the high voltage of the 10,000 volts at low pressure of 0.01 mm of mercury pressure. Now, by the high voltage of 10,000 volts, H2 gas breakdown because bond energy of 434 kilojoules is breakdown because of the high voltage. And you get H atoms. These H atoms are bombarding with each other. Bombarding means what? Collision. Because of these collisions, energy liberated. The liberated energy appeared in the form of the blue color of light. Now the blue color of light passing through the prism, you get different kinds of the emission of the spectral lines are observed. These spectral lines are falls under different categories. Now, the spectral lines are falls under different categories. As I said, so this is the what, Nana? Nucleus. This is called K orbit. This is called L orbit, and this is called M orbit. This is called N orbit, and this is called O orbit. It's very easy explanation, and this is called infinite orbit. Go on like that. Infinity orbit means what? Infinity orbit means valence shell, right? Valency means what? Infinity orbit. Now basing on that, so this nucleus K, L, M, N, O, P, Q like that go on infinity. Now see, so we can see different types of the spectral lines observed in different types of the series. Now I'm writing in the form of a table. Name of the series. You write this table and you get 8 marks out of the 8. Name of the series, So this is N1. N1 means what? Ground level. N1 means what, Nana? Ground level. N2 means what? Excited level. N2 means what? Excited level. Like this. Now the first one is what? Lyman series. Lyman series is observed in the UV region. That means for the Lyman series, the ground level is what? Ground level N1 is equal to 1. 1 means KRP. 1 means what? KRP. So N2 means what? Excited level. That means what? 2, 3, 4, so on like that, up to infinity. So that Lyman series is completed. And come to the Balmer series. For the Balmer series, what is the region? Visible region. UV means ultraviolet region. Balmer series is visible. The lines are visible to the naked eye. That is called Balmer series. For the Balmer series, what is the ground level? For Balmer series, the ground level is 2. That means LRP. And what is the excited level? 3, 4, 5, 6, so on, infinity. Infinity means fashion. Lyman Balmer, and go to the fashion. This one is what? Fashion series. It's very easy explanation. Fashion series means what? Near infrared region. Near infrared region. That means what? Here N1 is what? 3. For 3, this is what? K, L, M shell. And N2 is what? 4, 5, 6, 7, go on, infinity like that. Lyman Balmer fashion. And this one is what, Nana? Bracket. Bracket series. For bracket series, what you write? Infrared region. For infrared region, the ground level is what? 4. K, L, M, N is the ground level. And exit level 5, 6, 7, 8, so on, infinity like that. And next one, Lyman Balmer fashion bracket. You tell me fun series. For fun series, what is fun series? For fun series is what? Far infrared region. For far infrared region, N1 is equal to 5. And N2 means what you write? N2 is equal to 6, 7, 8, 9, so on, go to infinity like that. We write in the form of a table. Now we get full marks because the table is very, very important. But see, for some essay questions, any tabular forms are there. But if you write the table, the examiner is very nice to impress to get 8 marks out of the 8 marks. And by using this different kinds of series, so when blue light of the H2 gas passing, the emission of the blue light of H2 gas passing through the prism, you get 5 types of the series like this: Lyman, Balmer, fashion, bracket, fun. So by using some formulae, we have to find out wavelength of these spectral lines. Now the formulas are very important to impress the examiner by the formulae also. Now see the formula. So wavelength of the given spectral line. This is the formula we can apply. Wavelength of given spectral line. Wavelength of the spectral line is equal. What is the formula is given? 1 by lambda is equal R into Z square 1 by N1 square minus 1 by N2 square is the formula is applied for the wavelength of spectral line. Right? Here what is R? R means what? Better to write. It's called Rydberg constant. What is R? Rydberg constant. To make the impression of examiner, better to write the constant names. Don't keep like that R. Better to write that Rydberg constant. This value is 109,678 centimeter inverse. This is the Rydberg constant value. We also find out frequency of the spectral line. What you find out? Frequency. So frequency of the spectral line. Frequency of the spectral line is equal. Frequency mu is equal 3.33 into 10 power 15 Hz into Z square 1 by N1 square. What is N1? Ground state. N2 is what? Exit state. Yes or no? N1 is ground state. N2 is what? Students. Exit state. And also find out the energy of the spectral line. What you find out? Energy of the spectral line. Now see that energy of the spectral line is equal. So energy is equal 13.6 electron volt per atom into Z square 1 by N1 square minus 1 by N2 square. So this is the formula is used to calculate wavelength of the given spectral line, to calculate frequency of what? To calculate wavelength of the spectral line, to calculate frequency of the spectral line, to calculate energy of the spectral lines. Very easy, Nana. You can do the work like this. Definitely you got 8 marks out of 8 marks. And very well known about this Roots Academy. So one of the beautiful coaching center is located near the JEE campus. So last time the short term in the EAMCET over, just 1 month back APMCET is over. Nearly 850 members take the short term coaching and get the good ranks for the objective purpose of the teaching. But for the sake of the beneficial of the students, we give to the online platform of the free classes for the IPE to better improve yourself of the marks. Okay, yes, and go for Google. In the Google also, our academy is there, and please subscribe it, and you get the free classes for this IPE classes. No, right? Understood? So one of the best coaching center for JEE Mains, IIT Advance, NEET. Okay. Yes. So this is the formula we can apply for hydrolysis pattern. So the first kind of the question successfully completed. Actually, in the first question, 2 models completed. First one is Bohr's model and its limitation. Second one is what? Hydrogen spectrum explanation, line spectrum of hydrogen atom. And go for the next one. Now regarding the next question, see. How are the quantum numbers N, L, M, S are arrived? Explain the significance of these quantum numbers. Yes. First of all, this is one of the again beautiful question. Now see, how are the quantum numbers N, L, M, S are arrived? Now first of all, what is the meaning of the quantum number? Actually, the quantum numbers explains the exact position of dual nature of electron, the exact position of dual nature of electron present in the space around the nucleus in an atom, Repeat the statement once again. What is the meaning of quantum? Quantum means what? Quantum is a Greek word that means how much. Quantum means how much. Simply called a pocket of how much energy. So the quantum numbers explains the exact position. Tell me what I am saying. It explains exact position of dual nature of electron present in the space around the nucleus in an atom by derivation of what? By derivation of Schrodinger wave equation. By derivation of what, Nana? Schrodinger. By derivation of the Schrodinger wave equation, we get derivation of these quantum numbers except spin quantum number. From Schrodinger wave equation, so the principal quantum number is derived, azimuthal quantum number derived, magnetic quantum number is derived, but spin quantum number is not derived. Anyhow, these quantum numbers explain the exact position of the dual nature of electron in the space around the nucleus by using derivation of this Schrodinger wave equation. That is the statement of the quantum numbers. You refer any book, but the quantum number statement is not there in the books. N is explained, L is explained, M, S is explained, but the statement of quantum number is not there. You refer any book. That's why, so the listening of even the IPE classes are so important. For getting 60 out of 60, I am saying. Understood, Nana? Yes. And now we discuss about the significance of each quantum number one by one. First, we discuss about the first one is very easy, as I said. Significance of what? Significance of principal quantum number. Now, regarding significance of the principal quantum number small n, actually, as I said, for IPE examination, long answers and 4 marks answer, you write in the form of a point wise, better to get full out of the full marks. Yes. Now, the principal quantum number was introduced by the scientist Niels Bohr. This is very well known to you. And as principal quantum number n is equal to 1, that is kr bit, n is equal to 2, that is lr bit, n is equal to 3, that is mr bit, n is equal to 4, that is nr bit. All you are very well known. Now, by using this principal quantum number, so we find out maximum number of electrons in an orbit. Maximum number of electrons. Maximum number of electrons present in an orbit. Maximum number of electrons present in an orbit is equal to 2n square. Tell me what is the formula? 2n square. Now say for example, so is a k orbit, is a l orbit, is a m orbit, is a n orbit, o orbit, like that. Here n value is 1, n value is 2, m value is 3, n value is 4, o value is 5, like that. So what is the formula for maximum number of electrons? 2n square. 2 into 1 whole square is 2 electrons. Here 2 into 2 whole square, that is equal to 8 electrons. Okay. 2 into 3 whole square, that is equal to 18 electrons. Okay. 2 into 4 whole square, that is equal to what? That is the 32 electrons. Simple formula. It's very easy formula. 2 into 5 whole square, that is equal to 50 electrons are available in the given orbit. By using simple formula of what? By using simple formula of maximum number of electrons present in an orbit, that is equal to 2n square. Understood? Yes. Already this is the point I said. As the n value increases, energy of the orbit increases, and the radius of the orbit, energy of the orbit increases, radius of the orbit increases, size of orbit also increases. This is the next point. This point are they given in the Bohr's atomic model. And the next point is very, very important. See what is the next point. Now the next point is, now see the next point. Here, in an orbit, what I'm saying, in an orbit, or orbit is also called what? Shell. Orbit also called shell. In an orbit or shell, the orbit number is equal to number of suborbits available. Number of what? Suborbits available. One of the excellent points, students. In an given orbit, the orbit number is equal to the number of the suborbits are available. You ask a question, sir, how is explained, sir? Yes, very easy. And this is the point also given for the object examination also. The orbit number equal dash number of suborbits are available. Equal number of suborbits are available. Now, how it is possible? Sir, you ask a question. Simple answer. So, is a k orbit? Is a l orbit? Is a m orbit? Is a n orbit? Is a o orbit, like that. So, this is an what? Orbit number. So, for this orbit number, so what are the number of the suborbits are available? Suborbits also called what? Subshells. Number of the suborbits. Now, actually, in the k orbit, n value is 1. In the L orbit, n value is 2. In the M orbit, n value is 3. For N orbit, n value is 4. For O orbit, n value is 5. So here number of suborbit available is S is the suborbit available. Now, this S suborbit available in the first orbit of the one, that is called 1s. Number of suborbits. In the orbit 2, the number of the suborbits are available S, P. Now see the suborbits S, P, where they are available in the second orbit. That's why I write 2s, 2p. Simple logic. In the orbit 3, what are the suborbits are available? S, P, D available. Those are the suborbits are available. 3 suborbits equal to 3. Is matching? Orbit number equal to what? Number of suborbits matching or not matching? Yes, is matching. Now, SPD suborbits are available. In the third orbit, 3s, 3p, 3d. And in the fourth orbit, the suborbits S, P, D, F. Yes or no? What are the suborbits? How many are available? 4. The 4 suborbits equal to the principal quantum number 4, that means they are available in the fourth orbit, 4s, 4b, 4d, 4f. And in the fifth orbit, s, p, d, f, g available. That means 5 suborbits equal to orbit number 5. Now what you write? 5s, 5b, 5d, 5f, 5g, like that. So this is the significance of what? Principal quantum number. Significance of what, students? Principal quantum number. Understood what I am saying? Yes, no. And go to the azimuthal quantum number. Now regarding concept of the azimuthal quantum number, now that is the second quantum number. See, azimuthal. Actually, that azimuthal quantum number, actually this azimuthal quantum number also called subsidiary quantum number. The other name of the azimuthal quantum number is called subsidiary quantum number. Its symbol is taken as small l. Now, important point here, the value of the small l. The value of the small l explains what? This very easy point explains the size, energy, explains size, energy, shape of the given subshell. Shape of what I am saying? Shape of the given subshell or suborbit. Repeat the point once again. The L value explains what? The L value explains is very easy. IPE classes are very easy. Just you listen of the rules academic faculty given PDF notes and directly go to the examination. Definitely got 55 marks, give me out of 60. Damn sure I give that points. L value explains what? Size, energy, shape of the given suborbit available in the orbit. Suborbits were available? Available in an orbit. Available in an orbit. Now, here, and one more important point, L value is equal to n minus 1 value. What I'm saying? L value is equal to what? N minus 1 value. Yes. Now, based on this point, I'm saying this point is very, very important. Say, for example, L is equal to 0, that is called S suborbit. L is equal to 1, that is called P suborbit. L is equal to 3, that is called D suborbit. L is equal to 4, that is called F suborbit. L is equal to 5, that is called G suborbit, like that. Now, simple logic. L is equal to 1, the suborbit is called S. L is equal to 1, the suborbit is called P. L is equal to 3, the suborbit is called D. L is equal to 4, the suborbit is called F. L is equal to 5, the suborbit is called G, like that. Now, this L value, as I said, explains size, energy, shape of the given suborbit. Understood what I am saying? Simple logic. Now, here, L value, one of the nice point, L value not exceed N value. L value not exceed N value. That's why L value is equal to N minus 1. Not exceed means what? Say, for example, I'm saying N value is equal to 3. So what are the allowed L values? Allowed L values are, this is the point, very important. What's the point I said? L value not exceed the N value. That means N is equal to 3. Allowed L values are what? 0 is allowed, 1 is allowed, 2 is allowed, but 3 is not allowed. You ask the one question, how sir? 0, 1, 2 available? S. If N is equal to 3, so S is allowed, P is allowed, D is allowed. Therefore, what are the subshells are available? 3A subshell available, 3P subshell available, 3D subshell is available, like that. If N is equal to 4, what is the allowed L values? Allowed L values are 0, 1, 2, 3. That means what is allowed? S is allowed, P is allowed, D is allowed, F is allowed. Now, S, P, D, F, they are allowed in the fourth article. That means 4S, 4P, 4D, 4F, like that. This is the concept of what? Azimuthal quantum number, also called what? Subsidiary quantum number. Simple logic, no confusion to the explanation. It's very easy. Yes. What I'm saying, L value explains size, energy, shape of the given suborbit available in an orbit. L value is equal to what I'm saying, n minus 1 value. S L is equal to 0, S L is equal to 1, be like that. L is equal to 1p, L is equal to 2. See, sorry, L is equal to 2, that is what? D. L is equal to 3, that is F. L is equal to 4, that is what? G, like that. L is equal to 2, that is D. L is equal to 3, that is F. L is equal to 4, that is what? That is G, like that. See, this is the extent point. L value not exceed N value. See, N is equal to 3. What are the allowed L values? 0, 1, 2 only, but 3 not allowed. That's why SPD, suborbits are available as 3S, 3P, 3D, like that. This is the concept of what? Azimuthal quantum number. And come to the next one, magnetic quantum number. It's very easy explanation. Now regarding the magnetic quantum number, the symbol taken as what? Small m. Actually, this magnetic quantum number was given by the scientist Landé. Azimuthal quantum number given by the scientist, proposed by the scientist Sommerfeld, and magnetic quantum number proposed by the scientist Landé. Yes. Now, this is the very easy point. Now see, when an atom subjected to strong magnetic field, repeat the point once again, when an atom subjected to strong magnetic field, yes, Venkatesh, good evening, Venkatesh. When an atom subjected to strong magnetic field or subjected to strong electric field, now each spectral line divided into fine lines. Into which lines? Fine lines forms a fine spectrum of atom. That means one of the excellent, already this point is given the objective question also. Because in chemistry, some theory questions directly comes as the objective theory questions. That's the advantage of the chemistry IPE. In chemistry, some theory questions comes as the objective questions. So into the each spectral line divided into what? Fine lines. Now forms fine spectrum of atom. Forms what? Fine spectrum of atom. Actually, it's one of the excellent point. The fine spectrum of atom was explained by which quantum number? The fine spectrum of the atom explained by the magnetic quantum number. Repeat the point once again. Atom subjected to what? Strong magnetic field or strong electric field. Each spectral line again divided into the fine lines forms a fine spectrum of atom. This fine spectrum of atom was explained by the magnetic quantum number. Here, the reason now I'm set. The magnetic quantum number m value depends on the L value as m is equal to 2L plus 1 value. Now see, I set the point now like this. For example, L is equal to 0. That is called what? S suborbit. Therefore, m is equal to what we get? M is equal to 1. But 1 is taken as what? 0. Because why the m equal to 1 you get 0? Because for the S, L value is 0. See, if L is equal to 1, that is a P suborbit. For the P suborbit, m is equal to what you write? 2 into 1 plus 1, that is equal to 3. For 3, what you write? As the fine lines, minus 1, 0, plus 1. That means the suborbit divided into orbitals. That is the reason. What is the reason here? Each spectral line divided into fine lines. Why each spectral line divided into fine lines? That is your doubt. Because when atoms subjected to strong magnetic field, strong electric field, so the suborbit divided into what? Suborbit divided into orbitals of what? Orbitals of the px, py, pz. This is the beautiful reason for that. Understood what I am saying? Say for example, L is equal to 2. L is equal to 2, that is a D suborbit. Now M is equal to what you get? 2 into 2 plus 1 is equal to 5. So what are the orbitals that are available? Minus 2, minus 1, 0, plus 1 plus 2 like that. See, if L is equal to 3, now that is F sub orbit. If F sub orbit, now M is equal to 7. For 7, what you wrote? For 7, you wrote like this. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3 like that. This is the simple logic. So this is the explanation of what? Magnetic quantum number. So this magnetic quantum number was proposed by the scientist Lange. Therefore, principal quantum number, azimuthal quantum number, magnetic quantum number derived from the what? Schrodinger wave equation. Understood what I am saying, students? Easy explanation, no confusion now. And go to the last one, spin quantum number. Now regarding the spin quantum number, actually the spin quantum number was proposed by the scientists Uhlenbeck and Gauss-Smith. The scientists' names are what? Uhlenbeck and Gauss-Smith. So Uhlenbeck and Gauss-Smith, they proposed this what? Spin quantum number. Yes, this is very easy to explain. So this is a nucleus. So around the nucleus, electron is revolving in an orbit, maybe in the clockwise direction. If electron revolving in the clockwise direction, what I am saying, if electron is revolving in the clockwise direction, it can be shown by plus of symbol around the nucleus. So this is an orbit. If electron is revolving in the anti-clockwise direction, the symbol shown by the minus of. This is the spin quantum number. It's very easy, but for this spin quantum number have no experimental proof. The spin quantum number have no classical analog. What is the meaning of classical analog? Classical analog means, see, so they have no classical analog. What is the meaning of classical analog? It have no experimental proof, it's just an evidence. If electron revolving clockwise, that's shown by plus of, electron revolving anti-clockwise shown by the minus of symbol, as proposed by the Gauss-Smith and Uhlenbeck, have no experimental evidence to this spin quantum number. And this quantum number not derived from the Schrodinger wave equation. Not derived from what, students? Schrodinger wave equation. Now, 3 essay questions are completed. Yes or no, students, please respond. 3 essay questions. The first one is what? Bohr's atomic model and its limitations completed. Second one, hydrogen spectrum is completed. And third one is what? Quantum numbers explanation completed. Definitely have the one of the question for 8 marks. The first year chemistry paper dead easy, not like second year. Second year chemistry paper somewhat difficult. In the essay questions, A, B, C, D given, A, B sub questions given like that. But in first year chemistry, directly damn sure only one single question given for 8 marks. Like 3 or 4 questions like that. Only single question. Write postulates of Bohr's atomic model, write its limitations. What is spectrum? Write the line spectrum of hydrogen atom. Like that the questions are given. Chemistry marks are very easy for first year theory when compared to the second year chemistry, right? So this concept is completed. And go to the next concept. So define atomic orbital. Explain the shapes of SPDF orbitals with the help of the diagrams. Simple logic. Now, what is the meaning of atomic orbital? Simple logic. The space around the nucleus. See the statement. The space around the nucleus. The space around the nucleus where the probability of electron density, where the probability of electron density should be maximum. Probability of electron density should be maximum. Here maximum is what? Up to 95%. You ask 1 point, sir, what about 5%, sir? But 5%, yeah, this is for 4 marks. Yes, now this is the Venkatesh, Varshita. Now this is the 4 marks question, Varshita, Sai Varshita, right, Varshita? The space around the nucleus where, Varshita is clear, this is the 4 marks question, Varshita. The space around the nucleus where the probability of electron should be maximum up to 95%. You ask 1 point. Sir, what about 5%, sir? In that 5%, electron density equal to 0. That is called not. In the 5%, electron density equal to 0. That is called not. Now, this is known as what? Atomic orbital definition. Now, what is the point given now here? Now, see the point given here. No. Honey, yes, no, these questions are not remote. None. The first part is remote. So, which is the first part is remote? The first part means Rutherford model, Planck's quantum theory, photoelectric effect, Chandrakar, honey. Those models are remote, but Bohr's model is not, because Bohr's is the one of the important none. Bohr's concept is one of the nice concept. This part is not remote. Yes. So, the first part, Rutherford's atomic model, photoelectric effect, quantum theory. Okay, that part is remote. Understood, Nana, honey? Chandrakar, honey. Check the honey, right? Yes. And ask about what? Shapes of the S, P, D orbitals. The diagrams are very easy. Now go to the diagrams. Yes. The shape of the S is what? The shape of the S is spherical. That is very easy. The shape of the P orbital is what? So dumbbell shape. This is what? Dumbbell shape. For example, you want the shape of the PX orbital. That means dumbbell shape present along the x-axis. What about PY? PY means what? Dumbbell shape present along the y-axis. Dumbbell shape present along the y-axis. Okay, and dumbbell shape is present along the z-axis. So this is x-axis, that is y. This is z. Now this is x-axis, is a y-axis, is a what? Z-axis. Understood? And say dumbbell shape present along the z-axis like this. So this is the dumbbell shape present along the z-axis. This is x-axis. This is what? Y-axis. Now this is p-z-axis. Orbitals of the what? P. Right? Come to the d subshell. For d subshell, now see, this is what? dxy. Easy diagram. Next, what you write? dyz. Next, what you write? dzx. dxz like that. Now the dumbbell shape. In dxy, the double dumbbell shape present in between the axis like this. Just to write diagrams like this. Double dumbbell shape present in between the axis. In case of what? This is the dxy atomic orbital, dyz atomic orbital, dxz atomic orbital, right? And come to the double dumbbell shape present along the x-axis and y-axis. So dx square, dy square. This is x-axis, y-axis. This is what? dx square, y square atomic orbital. And come to x-axis, y-axis, and z-axis. Now see, so this is a diagram of what? dz square, like this. So simple question is a diagram. So this is what? Spherical. S orbital is what? Spherical. The spherical covers along the x, spherical covers along the y, covers along the z. This is px, py, pz, dxy, dyz, dzx. Present double dumbbell shape. So these are what? Double dumbbell shape present in between the axis. dx square, y square, dz square. The double dumbbell shape present along the axis. This is the next question. And go to the next question, Anna. And this is the one of the important question for 4 marks. Explain the dual behavior. Dual behavior of the matter. Discuss the significance to microscopic particles like electrons. See, Planck's quantum theory is not there. No need to explain this Planck's quantum theory because this is not there. No, but this is very, very important. Dual behavior of the matter. Right? Now, regarding the dual behavior of the matter, simple logic. For example, the matter composed of, say, the matter composed of microscopic particles. Matter composed of which particles, students? Microscopic particles. You tell me, what are the microscopic particles? The particles not visible to naked eye. The particles not visible to eye. They are called microscopic particles. The matter composed of the microscopic particles like what? Microscopic particles like atoms, molecules, okay, electrons, protons, neutrons. All are examples of microscopic particles. Now, the matter composed of these microscopic particles like atoms, molecules, electrons, protons, neutrons. So they have what? They have dual nature. What is the meaning of dual nature? Dual nature means what? Particle nature as well as wave nature. Repeat once again. What is dual nature? Dual nature means particle nature as well as wave nature. You ask one point. Why sir they exhibit dual nature? Simple logic. Because the atoms and molecules, electrons, protons, and neutrons, they have the because of the very least mass, the wave nature is more. Because of what I am saying, least mass, the wave nature is more. Now, how you ask a question? How sir they have the least mass? I said that point. Now see, according to Max Planck's quantum theory, one simple formula is there. According to Max Planck's quantum theory, so what is the formula? Energy is equal to h mu. Yes, according to Einstein theory, actually the Einstein theory is applicable to microscopic particles of the matter. What you write? Energy is equal to mv square. M means mass of the microscopic particle. V is velocity of the particle is moving. It means what? Planck's constant. Mu means what? Frequency value. Frequency of the microscopic particle having matter. Now, LH is equal to what you write? LHS is equal to RHS. Left hand side is equal to right hand side. Very good. From that, what you write? H mu is equal to mv square. H mu means what you write? H is c by lambda. Hv by lambda. Because frequency is equal to velocity by wavelength. Velocity means what? V by lambda. Understood? That is equal to mv square. This one is cancelled. Therefore, lambda is equal to what you write? H by mv. What is m? Mass of the microscopic particle present in the matter. What is v? Velocity of the particle present in the matter. That is equal to what you write? H by v. Now see, the mass is very less because the microscopic particle mass is what? Less or high. The mass is very less. That's why wavelength value is very more. That's why it has the dual nature. This is the reason for that. Most of the students don't know this reason. Just you by heart the reason. Most of the students know you don't know the answer, but you by heart that. Not by heart. You know that simple logic. The chemistry scoring is very easy. No confusion. Simple logic. Tell me what I am saying. Because the microscopic particle mass is very less. As for microscopic particle mass is very less. Now the wavelength is what? Very high. So wavelength and mass is less. That's why the microscopic particles has a what nature? Dual nature. According to Planck's quantum theory, according to Einstein's theory. Understood? Therefore, LHS equal RHS, H mu equal what? mv square. From that we get lambda equal h by mv. So this is the explanation given by the scientist de Broglie's concept. That's what this is also called what? De Broglie's dual nature of the matter. De Broglie's. What you write, Nana? De Broglie's dual nature of the matter. But that matter composed of the microscopic particles. De Broglie's dual nature of what? De Broglie's dual nature of the matter. This is the explanation. That means here, only the important point, the matter is composed of what? Microscopic particles like what? Atoms, molecules. Because atoms, molecules are also microscopic. They are not visible. Yes, our human body made up of a skin. Our skin is made up of a carbon. But carbon is not visible to the naked eye. They are microscopic nature. Yes, that is the one of the 4 marks question. Understood what I am saying? And see the next one. So, see, this is again the 4 marks question. This is the fifth one. ABT is a 1 4 marks question and BBT is a 1 4 marks question. What I am saying? ABT is a 1 4 marks question and BBT is a 1 4 marks question. Again here BBT, Harbour principle, Hund's principle, Pauli's principle. Again they have the excellent 4 marks question. In the 4 marks question may be given Harbour principle or Hund's, or may be given Harbour principle or Pauli's principle, or may be given Hund's rule and Pauli's principle, like that. But 3 are not given, students. 3 are not given. Any 2 given. write a brief note on Harbour principle and Kunststool. Or write a brief note on Kunststool and Polish principle like that. You write like that. So write a brief note on Kunststool and Polish principle like that. This is the simple explanation. So for the foremost question, and tomorrow class we discuss about this part. So every 1 hour, so we give the free online classes to you. Please utilize these classes. It's the best coaching institute near to the JNTU for the objective point for the IIT Advance, IIT JEE Mains, okay, and for NEET. But for the sake of the students, to make the more benefit to the students, we give the free YouTube classes for the IP students to make the better much score in your examination of October 25th onwards. So please utilize this as early as possible, Nana. Right, thank you very much. Now the next class is going on to you.